All right, geometry students. So I'm going to take over from Mr. Atkins and just explain example 4 and 5 to you. What you can see here is I've drawn in Joy's friend's car, and I'm just going to use that really quickly to show you a visual. So the idea is Joy's friend is driving along the road. At some point, the friend is going to stop, and Joy's going to come out of the cafe to the car, pick up her ticket, and then go on to the entrance. You can see where I've positioned the car now is obviously not going to be the optimum place, and so the objective in this problem is to get Joy to be as efficient as possible, lazy or efficient either way, and so we want her to be able to walk the shortest distance possible. Okay, and so to do this question correctly, what we're going to do is begin by, I'm going to just draw in the street over there, and I'm going to use that as a line of reflection. I'm going to get, so hopefully I'll be able to choose some colors that'll show up nicely. I'm going to take the cafe point, and what I'm interested in doing is going from the cafe point to the road, and I want a line of, I want to reflect that point over the street line, and so I'm going to use a copy over here. So I'm going to copy my line segment over here, if it'll copy eventually, and paste it on the other side. You, of course, should be using a straight edge in order to do this, in order to make sure your measurements are going to be accurate. So what I've done is I've reflected that point over here. If we were to call that point C, I'll call this point C prime. And then what I'm going to do is join point C prime to, let's say for argument's sake, point E, my entrance point, and the point at which line segment C prime E intersects with the road is going to be the point at which Joy's friend should be driving to give her her ticket. And so the route that Joy would then walk would be from point C. Let me just redo that. That didn't work out pretty as nicely as I wanted. So it's going to be from point C and then to point P and up to point E. So she's going C to P and then up to point E. Okay, and so essentially what we're after in this particular case, the question asked, find the coordinates of point P which allow Joy to minimize her distance. So that's what we're going to do. Let me show you a couple of things quickly. If we had instead chosen to use point E and reflected that instead, so I'm going to just do that relatively quickly and try to get that as accurate as I can. Hopefully that works out as accurately as I'm expecting. And then what I'm going to do is just take that exact same line segment and extend that. And what you should see is that that point P would have been produced irrespective of whether we had reflected C over the path of the road or whether we had reflected E. Okay, and so what remains to be done is for me to now show you why it is that that is the point that minimizes the distance. So let me change colors again here and let's focus on this. And so what you should know really quickly, so if nothing to do with this problem, here's point A, here's point B. If I said to you, what is the shortest distance between point A and B? You should know that the shortest distance between 2 points is going to be the line segment joining those 2 points. And so I'll just belabor the point a little bit. If on my way to point B, I went from A to C, and then from C to B, I know that that distance has to be longer than this distance because of the triangle inequality theorem, which says the sum of any two sides of a triangle is larger than the third side. And so we know that to go directly on a straight line, and knowing that, of course, is rhetorical because lines by definition are straight. So a line segment that joins 2 points is the shortest distance. So now let's go back over here. And so what I want you to think of is this distance over here, the distance from, or the length of segment C prime E. And then we're just going to do a quick little proof in here. So the shortest distance between point C prime E is going to be the line segment that joins C prime to E. And now let's just take a really quick look at this. So if we look at our triangles that we've created here, we know that those two segments are congruent because that was a reflection. We know that this is a 90-degree angle, and we also know that that segment is shared between these two triangles over here. This triangle over here, oops, sorry, you can't see that very well. Let's try that again. This triangle over here and this triangle over here. And so those two triangles are in fact congruent to each other. And if those two triangles are congruent to each other, that means this segment over here is equal to this segment over here. And what that basically means is that the distance from C prime to E is the same as the distance from E to P and then from P to C, because those two segments are equal. And so effectively we know that the sum of those two distances is the length of C prime E, and that proves that it is the shortest possible distance. Okay, all right, and so now we're going to do a second example which uses a similar conceptual idea, but this particular example is less concerned about the distance traveled and really more concerned about the path that we're going to take. Okay, and so I'm playing a game of pool. I'm trying to get ball A, my cue ball, to hit ball B into the pocket so that I can win the game. As you can see, those two red balls are in the way, and I'm not allowed to make contact with either of those balls. Otherwise, I'm not going to win the game. And so the idea here is you're going to use a bank, as they say in pool. You're going to bounce it off one of the sides. And so the thing that you need to think of is wherever you're planning to bounce the ball, you need to think of that as your line of reflection, okay? And so I'm going to take ball B, and I'm going to measure the distance from ball B to my wall where I'm going to bounce it off, or to the side of the pool table where I'm going to bounce it off. I'm going to measure that, of course, at 90 degrees. Shortest distance between a point and a line is, of course, at 90 degrees. I'm going to take that same length the other side, paste that over there. So I've got these two things are congruent, and I'm now going to take, let me just draw in a quick representation. So that over there is point B. This would be point B prime. So the mirror image of B reflected over this line, which is the line that runs along the edge of the pool table where you would bounce the ball. To now figure out what our path is going to be, if I join B prime to A, that tells us where along the side of the pool table we want to bounce the ball. And so basically I'm going to hit my ball from point A along this to, let's call it point P again, and that will allow it to bounce off and hit ball B into the pocket without touching either of the red balls. Okay, and so the key here is to reflect your target, the thing you're trying to hit, over the line or the wall that you're planning to bounce the cue ball against. Okay, and so that should take care of that. Feel free at this point to pause the video and take care of your worksheet, which is below. For those of you who are interested, I'm going to take an extra minute or two just to show you, if you want to get a little bit fancy, a different shot that you might have made on this pool table if you wanted maybe to show off a little bit. Okay, so I'm going to add some more in, or I mean, realistically, if we consider that there may be other balls on the table that are blocking. And so we'll add in a little bit of a fancy extra here. And so I'm going to put in another line of reflection here. This would be, of course, if I were bouncing the ball off that side. And so I'm going to just reflect my cue ball over there. So let me get mine as accurately as possible. I'm looking for a 90-degree angle, and I'm looking to copy the length of that segment. Paste that over here. All right. And that is going to be essentially a reflection of A, so that's going to be A prime, and then I'm going to join B prime to A prime, and I'm going to show you as an alternative what you might have been able to do. And let me see if I can use the highlighter. Hopefully it'll show up nicely here, and I'll use some pink. That what you could have done instead was taken that A cue ball, bounced it off there. That would have allowed it to ricochet off and hit that point there, which in turn would have allowed it to go and strike point B, or the ball, into the pocket. And so if you want to show off a little bit, that would have been our alternative. Or of course, if there was a little more traffic in terms of red balls that were blocking your path. Okay.